In Lesson 13, we're going to find out why the divisibility rules work for 3 and 9, and we're going to use our answers from Lesson 18 to help us. Here, we need to figure out whether 1, 10, 100, and 1,000 were divisible by 3 without a remainder. And as you can see here, 1, 10, 100, and 1,000 were not divisible by 3, and they all had a remainder of 1. So let's circle no for all 4 of these problems, and they all had a remainder of 1. And guess what? 10,000, 100,000, and 1,000,000 will not be divisible by 3, and they will all have a remainder of 1. Let's take a look at the statements on the right-hand side. Letter A, draw a star above the first place value name that's divisible by 3. And as you can see here, we don't have any yeses. None of the place value names were divisible by 3. So we don't draw a star above any of the place value names. Letter B, which of the place value names are evenly divisible by 3? And we saw that none of the place value names are evenly divisible by 3. Letter C, no matter what place value name you divide by 3, you will always have a remainder of 1. So write it down. Let's take care of part 2. We're going to learn why the divisibility rule for 3 works. And the example that we have is 252 divisible by 3? So you'll notice we have a model for 252. Take a look at this first 100 here. Is 100 divisible by 3? And you saw here that 100 is not divisible by 3, and you're going to have a remainder of 1. So in this 100 block here, shade in our 1 remainder. Let's look at the next 100 block. Is this 100 divisible by 3? Again, the answer is no. You're going to have a remainder of 1. So shade in that 1 remainder. Now let's look at the tens. Look at this first 10 here, and is this 10 divisible by 3? Taking a look here, 10 is not divisible by 3. You're going to have a remainder of 1. So shade in the 1 remainder. Let's take care of the rest of the tens. This 10 will have a remainder of 1. This 10 will have a remainder of 1. So will this 10 and this 10. Now let's take care of the ones column. Is this 1 divisible by 3? And as you can see here, 1 is not divisible by 3. You'll have a remainder of 1. So shade in the remainder. And this 1 here is also not divisible by 3. You're going to have a remainder of 1. So shade it in. Now take a look at the bottom of the chart. It says, draw the remainders, then divide them by 3. So here, the 200s gave us 2 remainders. So draw them in this space. The 510s gave us 5 remainders. So draw 5 remainders in the space below. And the 2 ones gave us 2 remainders. So draw them here. Now let's divide the remainders by 3. 1, 2, 3, put them into a group. 1, 2, 3, put them into a group. 1, 2, 3, put them into a group. And you'll notice that there are no more remainders left. So 252 is divisible by 3. Now for the shortcut. Notice that the 200s gave us 2 remainders. The 510s gave us 5 remainders. And the 2 ones gave us 2 remainders. So we actually didn't need to draw all this out. All we had to do was add 2 plus 5 plus 2. 2 plus 5 plus 2. Let's write down 2 plus 5 plus 2. And that gave us 9. And you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's answer the two questions. Is the sum of the digits divisible by 3? And as you can see here, 9 is divisible by 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So we'll circle yes. Is 252 divisible by 3? And the answer here is also yes. So once again, here's the divisibility rule for dividing by 3. Add up the digits in the number, and if the sum is divisible by 3, then the entire number is also divisible by 3. Let's finish up the lesson. The same logic for the divisibility rule for 3 also works for the divisibility rule for 9, because 9 equals 3 times 3. Let's keep going. Just add up the digits in the number and see if the sum is divisible by 9. And here's an important note. This will not work for higher powers of 3, such as 27. And the reason for that is powers of 10, some of them are 1, 10, 100, and so on, divided by 27 do not always give you a remainder of 1.